Okay, so we're going to graph the sister, which is cosine. So whenever you see secant, think cosine. So we're actually graphing, we're plotting the points for the cosine, 2x plus pi plus 1. So whenever you're graphing sine, cosine, secant, or cosecant, you always start by answering the question, where do we start? And the start is the phase shift. So take your parentheses and set this equal to 0. So my start, if I take 2x plus pi and set that equal to 0, go ahead and solve that for x. So I'm going to subtract pi and divide by 2. So I get x equals negative pi over 2. So this is going to start, because it's negative, I'm going to write for phase shift, it's going to go to the left, pi over 2, which is the same as 90 degrees. So I'm counting by 45s. So if I'm counting by 45s, or pi over 4, that means that I have to hop twice to the left. So this is my start, right here, because this is negative 90. If I'm counting by 45s, this will be 45, and this is negative 90. So that's my start, and I just like to kind of mark that there so I know that's my start of my wave, because it's a pattern. So I just need to figure out where to start my pattern. So I'm starting the pattern right there, right here. That's my start. And the end happens at the end of the period. So the end, I have to figure out how long is the period for this function. So all four, the first four, cosine, sine, and the sisters, secant and cosecant, they all have the formula is 2 pi over b to find your period. This is how you find the period for these four. And b is always the number in front of x. So for this one, x, you see how it has a 2 right here? So that 2 means that my period is 2 pi divided by 2. And what is 2 pi divided by 2? Just pi. So the period is pi. So let's write that here. So in the examples we did yesterday, it was 360. So I would have to hop 8 times to get to the end. But 45 times 4, and the more you practice it, the more you'll just know that, okay, 45 times 8 is 2 pi. 45 times 4 is 180, or pi. So I'm actually going to take, or pi over 4 times 4 is pi. So I'm going to only hop 4 times to get to the end. So 1, 2, 3, 4. So put an n right here. That's my n. So we have a much shorter period for this one. It's much shorter. Okay, so I know my start and I know my end. So now we're ready to plot our points. There's 5 points. Now cosine starts at the top. Then it goes down to the middle, hits the bottom, back to the middle, and it ends at the top. So when I do one full revolution for cosine, because the cosine, if you look at the unit circle, the cosine starts at 1, which is the top of the wave. Okay? So now let's figure out what these numbers will be in relation to this example. So my midline is at 1. So where it says vertical shift, right, that it goes up 1. So this wave is going to move up 1. Well, this is not a wave because we're graphing the secant. But it's we're moving up 1 because of this K value. And what's the amplitude of this? Now, even though it's not a true amplitude, but for this cosine function, what is this number in front of cosine? What's the amplitude of this one? The number in front of, you might be saying something, I just don't hear you. You know, we got masks on, so it's hard to hear. So what is my amplitude? 1, okay? So here in my pattern, so where it says the midline, my midline is 1, so I'm going to put a 1 right here so you guys can kind of, my midline is 1. And because of that amplitude, I'm going to add 1 to get to the top. So what is 1 plus 1? 1 plus 1 is 2. And then 1 minus 1 is 0. So my numbers are 2, 1, 0, 1, 2. So in this period, I have to hit all 5 of those points. So at the start, where I identify the start, I'm going to put a point at 2 because that's the start. Then I rotate down to 1, hit 0, back to 1, back to 2. All right, now don't connect it because remember, we're not graphing cosine. We need the points, but we're not going to connect it. But finish out the pattern. So I'm just going 2, 1, 0, 1, 2, 1, 0, 1, 2. Go the other way. Okay. Okay, so let's draw in our asymptotes. Now, our asymptotes are going to occur at the midline, which is 1. So every time you have a point at 1, because that's my K value, I want you to draw in an asymptote. So let's draw an asymptote in at every place where you have a point at 1. So it's going to be a lot more because our period is only pi. It's every 90 degrees that we have an asymptote. So the ones we did yesterday, we had an asymptote every 180 degrees. But this one, because our period is only 180, we have our asymptotes every 90 degrees. So every time you have a point at 1, you just need to draw in your asymptote. All right, and every time we're at the top, which in this example is 2, you have a smile. And every time you're at 0, you have a frown. So the top of this wave is 2. So we have a smile, and then you just keep going back and forth. Back and forth. Smile, frown. Okay, so let's go ahead and fill in our other characteristics here. So let me make myself some space. So the first thing I think I usually start off with is the asymptote. So I'm going to actually write that, the vertical asymptote, just because I want you all to be able to see it. I'm writing it at the top. So my vertical asymptote occurs at x equals. So we have our first asymptote here. And what is that? What would that be in radians? Pi over what? Pi over 4, because that's 45 degrees. So this first one is at pi over 4. And then we have one every 90 degrees. So it's every plus or minus pi over 2 n. That's my vertical asymptote. My domain is all real numbers. And then you would have to say that x cannot equal pi over 4 plus or minus pi over 2n. The range, and I'll also write this here so you can see that. So for my frown, the frown is negative infinity to 0. So negative infinity to 0, put a bracket. Union. And then my smiles are 2 to infinity. So that's my range. So we use the amplitude of cosine to graph it, but the actual graph of secant does not have an amplitude. Okay, so where it says amplitude, we're going to say NA, and we don't generally ask you that on for a secant and cosecant, so I'm actually going to take that off for next year, but you guys have it, so you know it's okay. And that's it. That is your graph. That's example 8. Okay, so first of all, tangent is equal to, the definition of tangent is sine divided by cosine. That is how you find tangent. So tangent equals sine divided by cosine. Okay, so because it's one of our quotient ratios, meaning that we have to divide the other two, we have to divide to find it. Every place on our unit circle where cosine, so wherever cosine is 0, tangent is undefined. Because you cannot divide by 0. So I want you to look at your unit circle, if you don't know it yet, and tell me where is cosine 0. What two places on the unit circle do we have a cosine of 0? Because that's where you want to draw your asymptotes. We have at 90, I heard Sarah say 90. So at 90 degrees, we have asymptote. So let's go ahead and draw in our asymptote at 90. And again, I'm counting by 45. Just because I think that's easier for me. So I'm going to draw in my asymptote at 90 and then 270. And then to continue that pattern, so if you look, it's every 180 degrees we have an asymptote. So let's continue. Let's make another one, 4 to the right, and then let's go 4 to the left, because it's a pattern. Okay. So let's look at what's happening in between. So look at your unit circle. So we figured out that we have our asymptotes on our y-axis here. So let's figure out what's happening in between. So that would be what's happening in these quadrants with tangent. Okay, so the first thing is, what would our tangent be? What is our tangent at 0? So what's the tangent of 0 degrees? So look at your unit circle and see if you can figure out, what is my tangent at 0 degrees? What do you think the tangent of 0 degrees is? So if you take the sine and divide it by the cosine. So let's look at your unit circle. What is the sine of 0 degrees? So tangent of 0 degrees, because it's just a pattern. So once you figure out the pattern, the rest of it is really simple. So tangent of 0 degrees is going to equal sine of 0 degrees divided by the cosine of 0. So look at your unit circle. What is the sine of 0 degrees? And the cosine of 0 degrees is 1. What's 0 divided by 1? Okay, so let's go ahead and put a point at 0, 0. So right in between, we have our asymptote. Now, the thing about tangent that makes it really simple is that you have your 45s. Now, I would not recommend that you try to graph the tangent of 30 or the tangent of 60. But the tangent of 45 is really easy to find. What do you think the tangent of 45 would be? So look at your unit circle. If you take the sine of 45 and divide it by the cosine of 45, notice that they're the same. It's square root of 2 over 2 and square root of 2 over 2. So if you divide two numbers that are the same, what do you get? It doesn't matter what it is. If you divide two numbers that are the same, you get 1. So the tangent of 45 degrees is 1. So we can put a point at 1. And then the tangent of negative 45 degrees, which is coterminal with 325. So look at 325 on your unit circle. What do you think the tangent of that angle would be? Is it 1 or negative 1? Negative 1. So this is what this looks like. One revolution of tangent looks like this. And you can't go through the asymptotes. So we're just going negative 1, 0, 1. Draw your graph. So now that we have that, let's go ahead and fill in our key components for tangent. So we have asymptotes. Our first one occurs at 90, which is pi over 2. So at x equals pi over 2 plus or minus pi n. So we have a vertical asymptote at 90 degrees plus and minus 180. Your domain is all real numbers. X cannot equal pi over 2 plus and minus pi n. Now, tangent, notice that we don't have a break in our y values though. So in our secant and cosecant, we had a break, which is why we had a union. But for tangent and cotangent, if you trace it up vertically, it's continuous. So our range is all real numbers. And the period for tangent and cotangent is 180. So your formula for period is pi over b. So instead of 2 pi over b, it's just pi over b. So tangent and cotangent have a different formula. So in this function here, we don't have a number in front of x, or that number is 1, I should say. So we're taking pi and dividing it by 1, so our period is only pi. All right, let's go ahead and try to graph cotangent, and then we will end there. So cotangent is cosine over sine. So now your asymptotes are going to occur where sine is 0. So look at your unit circle and figure out where is sine equal to 0, and draw your asymptotes in. So cotangent is cosine over sine. So wherever sine is 0, you have an asymptote. So sine is 0 at 0. And it's also 0 at 180. So go ahead and draw in your asymptotes. Starting at 0, and then you have one every 180 degrees. So now let's go ahead and look at our unit circle. And let's work in between 0 and 180. So let's start at the middle. Let's start with 90. So let's figure out what the cotangent of 90 degrees is. So to figure out the cotangent at 90 degrees, you need to take the cosine of 90 and divide that by the sine of 90. So essentially, I'm doing these 3 points. So this is 45, this is 90, and this is 135. So I'm going to find the cosine of these 3 points. So go ahead and look at your unit circle. I did not mean to write cosine. I meant to say cotangent, sorry. We're going to find the cotangent of 45 and the cotangent of 135. Okay, so go ahead, see if you can figure out, because these are my 45, 45, 90. So these are easy to find. It's either 1 or -1. So go ahead, look at your unit circle and see if you can figure out those 3 numbers. So for 90 degrees, you should have 0. So let's go ahead and put a point at 0. So right there, that would be mine. And then what about the cosine of, the cotangent, I am so sorry, the cotangent of 45 degrees? What's the cotangent of 45? So if you take the cosine of 45 and divide that by the sine of 45, do you get 1 or -1? 1. So let's put a point at 1 for the 45. And then 135. The cotangent of 135, is that 1 or -1? -1. So let's put a point at -1. See, it looks similar to tangent, except the squiggle goes a different way. It's a decreasing graph, if you think about it like that. That is your pattern that you just need to repeat. So you're going 1, 0, -1. 1, 0, -1. Okay, so my vertical asymptotes. Not do that. Okay. So my vertical asymptotes occur at, my first one is at x equals 0 plus or minus pi n. So that's my vertical asymptote. My domain is all real numbers, except x cannot equal 0 plus or minus pi n. The range for tangent and cotangent is all real numbers. The period for tangent and cotangent for the parent is pi. And we have our asymptotes. So I'm going to stop there, give you guys 5 minutes to look over your unit circle, and we'll do the unit circle quiz.